Hello there. In this lesson, we're going to look at 4 different groups of organic molecules that all have one thing in common. And you can see that in the molecules that are the active part of these different spices and flavors from around your kitchen. So cloves is the first one here, and you can see that parts that stand out is you got one of these aromatic rings again. But there's also an oxygen here and an oxygen here. Ginger's got the aromatic ring, but also oxygen, 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 oxygen. Chocolate, no aromatics, but it's got some nitrogen. That's different, but also some oxygen. And over here we have another aromatic ring. There's oxygen again, peppermint, oxygen again. So the thing they all have in common here, if you haven't picked up on it, is the oxygens. And so there's different types. So you got oxygens where it's on the end of a chain. So an OH group, you got oxygens where it's in the middle. You've got oxygen double bonds in the middle of a chain, and you get oxygen double bonds where it's at the end. So we're going to look at the different names and properties for those features of various molecules and look at some of the reactions that are related to them. So our first group are called alcohols. Alcohols have hydroxyl groups, which are these OHs that are stuck onto various parts of a molecule. The first type or primary type of alcohol will be when the oxygen or the OH group is attached to a carbon that only has one bond to another carbon. And then if it's a secondary alcohol, the carbon it's attached to will be attached to 2 other carbons. And then if it's a tertiary alcohol, the third level, then it's attached to 1, 2, 3 other carbons, and that makes the difference. Alcohols are named with an OL group on the end, so that's convenient. This guy here would be propanol, because it's like propane with an ol group on the end. And this would be the same thing, except it's on carbon number 2, so you call this 2-propanol. And here we've got 2 OH groups. This has 1, 2, 3, 4, 5 carbons. So this is a pentan. We have it on carbon number 2 and 4. So 2,4-diol. So the hydroxyl group of alcohols is very polar. The oxygen is electronegative, or much more electronegative than the hydrogen, and so that creates a dipole, which causes one molecule with an OH group to be attracted to another. If you compare the properties, like the melting and boiling point of an alkane to its corresponding alcohol, you'll notice that the melting point for the alcohol or boiling point will be a lot higher than for the alkane. So a good example would be propane versus propanol. If you open the top of this, out comes the gas, and of course opening the top of this, some vapors might come out, but most of this is going to be a liquid. So we can see the difference there in their properties. If the majority of the molecule, though, is still nonpolar, then you won't see as big a difference when you add a hydroxyl group on it. So it sort of has to do with like the proportion of the molecule that is being represented. Long chains of carbon are going to be nonpolar, regardless of whatever small polar groups might be present. So alcohols can be formed by addition reactions, as you saw in the previous lesson. Remember that if there's different numbers of hydrogen, the hydrogen will go to the side with more. This one, it doesn't matter because it's the same number on both sides. And so you can put the OH group on whatever side you like. It'll be the same molecule either way. You can also have dehydration reactions, which are pretty much the reverse. And as long as you have the right catalysts or conditions, you can get the reverse reaction to occur and regenerate your alkene, as so. So our next group are called ethers. Ethers are molecules that have oxygens between 2 carbons, and they're also polar, and so they'll be water soluble and have slightly higher melting and boiling points than alkanes. Not as polar as alcohols, though. That OH group is what makes alcohols really polar. The formation of ethers can be done with a condensation reaction, which is a pretty common one that you'll see over and over again in many of these different organic molecules that we're going to make. A condensation reaction removes a water molecule between two particles and leaves one oxygen behind, or in order to connect them. And so what you're going to see here is the two carbons on either side of the oxygen in the middle, and that's what makes it an ether. The other product, of course, is going to be the water that was removed, and of course hydrogens all around here, so that each carbon has 4 bonds. So to name ethers, what you want to do is identify what the main chain, so the larger group of carbons, will be. That's going to be the end of the name, right? So in the first case here, it's going to be an ethane, because that's the larger side, and the second one is going to be a propane. And then with the smaller side, that's the part that gets the oxy suffix. And so this is going to be methoxyethane. And this one here has 2 carbons, so that's going to be ethoxypropane. So put the oxy with the side with the fewer carbons, and you're good. Our last 2 functional groups both have what's called a carbonyl group. A carbonyl group is when you have carbon double bonded to an oxygen. If the carbonyl group is on the end of a molecule, this R represents the rest of the molecule, then it's called an aldehyde. If that carbonyl group is in the middle of 2 parts of the molecule, so there's carbons on either side, then it's a ketone. So if you look at those spices that we had earlier, you can see that cumin is an aldehyde because the carbonyl group is on the end of the molecule. And ginger has a ketone in it because that carbonyl group is partway along that chain of carbons. So naming aldehydes and ketones is pretty straightforward. Aldehydes get an Al ending, ketones get an O-N-E ending. Let's have a look at a couple here. This has 1, 2, 3, 4, 5 carbons. So this is pent and 2-one. And if the ketone is on the 3rd carbon, then it'd be pent and 3-one. And if that carbonyl group is on the end, then it's just pent and mal. Now, because we have a number of different types of functional groups, if more than one is present in the molecule, you have to have a priority sequence in which to name them. So aldehydes and ketones, of the ones we've done so far, are of higher importance than alcohols and ethers that we did earlier. So what you do is you put the highest priority one at the lowest numbering, and then go from there. So we've got carbon 1, 2, 3, 4. So this is bute and 2-one, and it's got a hydroxy group here on carbon number 4. So you say 4-hydroxy. And for this last one, we've got carbon number 1, 2, 3, 4, 5. So this is a pent and mal again. And we have this methoxy group on carbon number 4. So 4-methoxy. So just arrange them so that the higher priority suffix goes on the end of the name, and then the others can be listed before that. So as long as you have a primary or secondary alcohol, you can make an aldehyde or a ketone using an oxidation reaction. So an oxidation reaction is when electrons are lost, but you're not going to be able to account for that very easily here. Oftentimes, just use a square bracket around an O to represent an oxidation occurring, and you can just change whatever hydroxy groups you have into the carbonyl groups that you need for an aldehyde and a ketone. So if the OH group is on the end, if it's a primary alcohol, you'll end up with an aldehyde, right? End up with this as your product, amongst other things. And if the hydroxy group is on a secondary carbon, then you'll end up with a ketone. You'll end up with this guy, with the hydrogens, of course, surrounding. The O with the square bracket represents an oxidation agent or some other substance that's going to be able to take those protons away and produce the double bond. So dichromate ion or permanganate ion is a good candidate for those ones. And then you can do the reverse reaction by hydrogenation, which is just putting hydrogen back on to either side of where this double bond is. An addition reaction just like we did in the last lesson. So you can undo this ketone and end up with your secondary alcohol with a hydration reaction. Be a hydrogen on this side and of course 3 hydrogens on either end. All right, hope that helped. Get lots of practice. We'll see you soon.